Hey guys, in this video we're just going to go over arithmetic sequences. So an arithmetic sequence just follows a pattern of adding a fixed amount from one term to the next. The number being added is a constant. So we're either adding the same positive number from one term to the next or the same negative number from one term to the next. You'll notice that arithmetic sequences are linear in nature when graphed. You'll see if you were to graph that arithmetic sequence, it would look like a scatter plot where we do not connect the dots because we can't have a part of a term. These sequences or patterns always start when x is 1. So our domain, our x values, consist of only counting numbers, such as 1, 2, 3, 4, 5, etc., while the range, our y values, consist of actual terms. So let's look at the graph to the right. If we were looking at those dots, our x value, our domain, is the term number. So our first term was 2. Our second term is 5. Our third term is 8. And I'm just going to stop here. If I wrote them out as a list, 2, 5, 8, etc., you'll notice from 2 to 5 we added 3. 5 to 8, we added 3. You should notice because we are adding a constant number from one term to the next, that's how we get that linear nature. Also, like I said, that positive 3 is going to be referred to as a common difference now that we're in the sequences unit. So on this slide, we're just going to practice finding the common difference and determining if something is an arithmetic sequence. So again, an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate, and that constant rate is called a common difference. So to go from 4 to 2, 2 to 0, 0 to negative 2, this might be easy to see that our common difference is a negative 2. If you were unaware of how to get that negative 2, that common difference, you could just take the second term, which is 2, and subtract it by the first term. Or take the third term, which is 0, and subtract it by the term before, which is 2. And then you'll notice that it's all negative 2s. Again, you don't need to show that work. You can just type it into the calculator if you can't do it in your head. So for here, because I see a common or a constant increase, in this case decrease, by negative 2, this is considered an arithmetic sequence. The next one, 18 to 16, we went down by 2, 16 to 15, down by 1, 15 to 13, down by 2. Because that negative 1 is not a negative 2, because I don't have a constant decrease at a constant rate, this is not arithmetic. And then the last one we're going to look at is 2 1/3 to 2 2/3. I added a third. 2 2/3 to get to 3, I added 1/3. 3 to 3 1/3, I added 1/3. Again, because everything is going up by 1/3 from one term to the next, we can consider this an arithmetic sequence. These numbers right here, that negative 2, is our common difference again. This one doesn't have a common difference for b. And then again, that 1/3 is going to be referred to as our common difference. Now we're going to get into writing an explicit arithmetic formula. The first thing that you want to do whenever you see a sequence is determine if that sequence is arithmetic. You don't know what geometric is yet, but again, if something is arithmetic, I'm thinking add. That's our key word. Once you determine that something's arithmetic, you need to identify your common difference, which again is noted with the letter D. Once you have your common difference and the first term, you're going to substitute it into the equation that they actually give you on your Algebra 1 reference sheet. So a sub n equals a sub 1 plus d times n minus 1. On the Regents reference sheet, you're going to see a sub n equals a sub 1 plus n minus 1 times d. It doesn't really matter if you put the d after the parentheses or before the parentheses, because once you substitute in your numbers, you're just going to type it straight into the calculator. Do not simplify on your own, just in case you mess up. Okay, so let's look at the components of this formula. A sub n is going to be like our y equals. A sub 1 is our first term, so the first number that they give you the sequence, and our d is our common difference, the number that we're adding by a positive or negative from one term to the next. N represents your term number, and the minus 1 always stays. It's just a part of the formula that they give you. So let's look at the next example. State the formula for the following set of numbers: 27 to 15 to 3 to -9 to -12. From 27 to 15, we are adding -12. 15 to 3, we're adding -12, adding -12, adding -12. Because we have a constant rate, we do have an arithmetic sequence. So from here, we're just going to look at the left-hand side. They're usually not going to tell you to state the first term and the common difference. That's just me guiding you through it. So our first term is always the first number in the list that they gave you for your sequence. So your first term, a sub 1, is going to be 27. And our common difference is the number that we used to get from one term to the next. So our common difference, which is d, is -12. So once you have those two terms, you're just going to substitute it into the formula above. So a sub 1, we said, is 27 plus n minus 1 times d, which is -12. The reason why I put the d in front of the parentheses, I know I didn't here because this is the formula that they give you in the Regents, is because people tend to think that you're taking n minus 1 and subtracting 12. You're actually distributing that -12, but your calculator will do it for you. So I like to put the d term in front. So -12 times n minus 1. Either of them will work. Okay, so now that we have a formula, it wants us to find the 100th term. So we said n represents any term. So here in this case, we're going to replace the n with 100 because we want the 100th term. So a sub 100 equals 27 minus 12 times, we said n was 100 minus 1. I know you could do 100 minus 1 in your head and get 99, but please just type everything right into the calculator as you see it. So we're going to do 27 plus -12 n minus 1. You can put the plus -12, or if you want to just write 27 minus 12 times 100 minus 1, you're still going to get the same answer. So our answer is -1161. For this next one, the third term in an arithmetic sequence is 8 and the fourth term is 18. State the formula for the arithmetic sequence. So they told us it's arithmetic. So once I see arithmetic, I'm just going to write down the formula that I need. Now I need our first term and our common difference. So I'm just going to list out, we know we have the third term, which is 8, and the fourth term, which is 18. So I need my first number and my second number. Since they gave us consecutive 3 to 4, I could figure out my common difference. How do I go from 8 to 18? So I'm just going to do 18 minus 8. That means I must have added 10 to go from one to the next. So what I need to do now is work backwards because I need my first term. So I'm going to work backwards to fill in term 2 and then term 1. So I need to figure out what did I add to this blank right here to get to 8. So the easiest way to do that is just do 8 minus 10. 8 minus 10 is -2. And to check it, if I take -2 and I add 10 to it, I will get my 8. Now I'm going to work backwards again. And I have to subtract 10 from that -2 to get -12. And again, I could check -12 plus 10 gets me my -2. So now that I have my first term and my common difference, I'm just going to substitute in right into my formula. So a sub n equals my first term, which is -12, plus -2 and minus 1. Again, you're not really going to ever see the plus minus, so you would say a sub n equals -12 minus 2 times n minus 1, or you're just going to see it where your d term, your common difference, is on the right side. Usually, again, you would see it like this as a multiple choice. A pattern of blocks is shown below. Write an equation to represent the pattern. So my first set of blocks, or my first term, has 2 blocks. My second term has 1, 2, 3, 4, 5, 6 blocks. My third term has 10. And my fourth set of blocks, or my fourth term, has 14. So I have to write an equation. Let me check to see how I go from one term to the next. 4 to 6, I added 4. 6 to 10, I added 4. 10 to 14, I added 4. So my common difference is 4, and my first term is 2. So once I have those two things, I'm just going to substitute into my formula. A sub 1 plus d times n minus 1. That's my final answer. You can leave it like that, or because they did not tell you that it had to be written as a sequence, you could technically just do L1, L2, stat calc 4 to get an equation. If you were to distribute that 4 out to the parentheses, you would notice an mx plus b form. But again, since we're in sequences, I figured it would be best to practice just by plugging it into the formula. So to recap, whenever we think of arithmetic, we're thinking adding the same number. And again, explicit form is just a quick way to get any term in that sequence by replacing the n with the number of term that you're seeking.